In this problem, we're asked to solve a given quadratic equation using the quadratic formula and following the steps listed on page 318. So the first step on that page is to write the given equation in standard form. This equation is not in standard form. I'm going to write it in standard form by moving the 3x over to the left, subtracting 3x minus 3, and setting it equal to 0. This step also includes identifying the coefficients a, b, and c. So in this case, a equals 1, b equals -3, and c equals -3. Step 2, we're going to graph the equation and see how many times it crosses the x-axis. So if you do a sketch of this graph on your graphing calculator on a standard window, you're going to get a graph that looks something like this. Crosses the x-axis in 2 locations, and if you use your intersection process, you're going to find that x1 is approximately, -0.791, and x2 is approximately 3.791. Step 3, let's go ahead and use the quadratic formula. So x equals -b, notice the use of parentheses, plus or minus square root b in parentheses squared minus 4. A is 1, c is -3. All of that, the entire thing, is over 2 times a. If I simplify, -3 is +3, plus or minus square root. -3 squared is 9. This computation should always be positive. Negative times a negative is going to be a positive. 4 times 3 is 12, divided by 2. If I combine under the radical, I get 3 plus or minus square root of 21 over 2. Step 4, I'm going to split this into 2 parts, and then I'm going to compute x1 equals 3 minus square root of 21 over 2. And be careful that your fraction bar does not start to disappear and only go under the radical part. It goes under the entire numerator. x2 equals 3 plus the square root 21 over 2. So if I put this in my calculator, I need to be pretty careful how I do that. I can either put in this part first and then divide by 2, or I can put this numerator all in together with parentheses and then have the denominator as well. But either way, I should end up with -0.791. And for x2, 3 plus the square root of 21 over 2 should be approximately 3.791. So my exact form for these two solutions is this column. My approximate form is this column.